Alrighty, we're going to do some graphing radicals by hand. Now, if you read the directions here, it says pick three negatives. We're going to do the square root of x. If I do -1 and I try and take the square root of -1, that's actually not a real number. So we're trying to illustrate that to you that these graphs have a restricted domain. And we're going to talk more about domain in a second. But the first number that I'm actually able to take the square root of is 0. Now, when I'm taking square roots, I want to think of my perfect squares, and since we're usually on a 10 by 10 grid, I'm going to pick perfect squares that are less than 10, so 0, 1, 4, and 9. And when I plot these points, if I plug in 0, the square root of 0 is 0, the square root of 1 is 1, the square root of 4 is 2, and the square root of 9 is 3. So I'm going to plot those points 0, 0, 1, 1, 4, 2, and 9, 3. And you should remember from the family of functions unit that this is a quadratic on its side. It's a parabola that's been tilted over. We don't draw the whole parabola for reasons we'll talk about more later, but we just draw the top half of the parabola so that it's still a function. Now, the domain of the function, to find the domain, what you do is, I'm going to type this because I type faster and better, you set the radicand greater than or equal to 0, okay, and solve for x. So the radicand, if you don't remember what that word means, the radicand is the part underneath the square root. Let's make that red so it's nice and easy to see. The part underneath the square root in this problem is just x. So the domain in this function would be x, and we'll say greater than or equal to 0. Now the domain is the inputs that give real outputs. When you take Algebra 2, you'll talk about imaginary numbers. In this class, we need real numbers only, so the domain of this function is all of the numbers that will give you real outputs. You can look at the domain on the graph and say, hey, look, the smallest x value here on this graph is 0, and it goes to the right. So the domain of the function is 0, greater than or equal to 0, 0, and all the numbers bigger than 0. If you look at the graph, your domain should be where it starts, where the function starts. And that's why we find the domain first, so that we can determine where we're going to make our table. The things you need to take from this parent function, the square root of x, are we're trying to take the square root of those functions and define the domain. You should set the radicand, the part underneath the square root, greater than or equal to 0. So let's try a couple problems here. First thing we're going to do is we're going to find the domain. So we're going to set 2x plus 4 greater than or equal to 0, and we're going to solve. So that means 2x is greater than or equal to -4, and when you divide, x is greater than or equal to -2. So x is greater than or equal to -2 is our domain, and that means we're going to start our table at -2. Now we're trying to do this without a calculator, so if I do 2 times -2 plus 4, I get -4 plus 4, which is 0, and the square root of 0 is 0. So my first point is right there at -2, 0. What's tricky about square roots is that you don't want to take the square root of really gross numbers. You only want to take the square root of, again, 0, 1, 4, and 9. We've already taken the square root of 0, so what I'm going to do to figure out what I should plug in is I'm going to set the radicand equal to those numbers. I'm going to do 2x plus 4 equals 1, 2x plus 4 equals 4, and 2x plus 4 equals 9. And this will help me give me my x values that I'll be able to take the square root of. So if I subtract 4, I get -3, and when you divide by 2, 3 halves is -1.5. I should do that one next. Subtract 4, 4 minus 4 is 0, 0 divided by 2 is 0. I should do that one, x equals 0 next. And 2x equals 5. 5 halves as a decimal is 2.5, so that's the last one I'm going to plug in. Now, you don't have to do a lot in your head here because you know how these things are going to turn out. If I plug in -1.5, I'm going to get 1. And what's the square root of 1? 1. If I plug in 0, I'm going to get 4. What's the square root of 4? 2. If I plug in 2.5, I'm going to get 9. What's the square root of 9? 3. So now I have my table, -2, 0, -1.5 is at 1, 0 is at 2, and 2.5, 1, 2.5 is at, oh, the square root of 9, I'm sorry, I got to go back. That's 9, and the square root of 9 is 3. So 2.51, 2.5, 3, like that. So it should look like that. Again, it's a parabola on its side, and it's been cut in half so that it's a function. Let's try another one. First thing we'll do, set the radicand greater than or equal to 0, so x is greater than or equal to 8 is the domain. Now I know in my table I'm going to start at 8. But to find other points, I'm going to say x minus 8 is 1, x minus 8 is 4, and x minus 8 is 9. I'm picking these numbers because these are perfect squares. So if I solve this equation, I get x equals 9. If I solve this equation, I get x equals 12. If I solve this equation, I get x equals 17. So those are the x's I should use. Now this one's a little trickier. If I plug in 8, I'm going to do the square root of 8 minus 8 plus 6. So 8 minus 8 is 0, the square root of 0 is 0, and 0 plus 6 is 6. If I plug in 9, 9 minus 8 is 1, the square root of 1 is 1, 1 plus 6 is 7. If I plug in 12, 12 minus 8 is 4, the square root of 4 is 2, 2 plus 6 is 8. And if I plug in 17, 17 minus 8 is 9, the square root of 9 is 3, and 3 plus 6 is 9. So 8, 6 is right here, 9, 7 is right there, and then I'm off the page a little bit. I'll try and get one more at least. 12, 8 is about there, so this one's tricky to sketch, but it looks like that. And you might remember, you should remember from family of functions, that this function has been moved right 8 and up 6 from the original. So if I look, I went right 8 and I went up 6, and now it's just like the original parent function I did at the beginning. Let's try another one. Set the radicand equal to 0, or greater than or equal to 0. So 3x is greater than or equal to 12, x is greater than or equal to 4. That's the first point in my table. If I plug in 4, 3 times 4 is 12, 12 minus 12 is 0, and the square root of 0 is 0. I need to figure out more values I can use, so I'm going to write 3 little helper equations. Add 12, 3x equals 13. 13 divided by 3 is 4.3 repeating. Add 12, 3x is 16. 16 divided by 3 is 5.3 repeating. So 4.3 repeating, 5.3 repeating. Add 4. Why is it 4? That should be 12. Oh, I wrote 4 over there. 3x minus 12. Add 12. 3x is 21. X is 7. So now, what I can do is I can plug these in. But again, I know what's going to happen. If I plug in 4.3, I'm going to get 1. The square root of 1 is 1. If I plug in 5.3, I'm going to get 4. The square root of 4 is 2. If I plug in 7, I'm going to get 9. The square root of 9 is 3. So 4, 0, 1, 2, 3, 4. 4.3 is at 1. 5.3 is at 2. And 7 is at 3. So it looks like this. This one's been stretched out a little bit. But it's still a parabola. We just don't draw the second half. Okay. Couple more. Domain. X minus 2 is greater than or equal to 0. So x is greater than or equal to 2. That's your domain. So on my graph, the first x value I have will be at 2. So I'll make a table starting at 2. Set the radicand equal to other perfect squares. 1, 4, and 9. And you should be able to do this in your head for the easier ones. X equals 1 plus 2, x equals 4 plus 2, x equals 9 plus 2. So I'm going to plug in 3, 6, and 11. Why am I picking those numbers? Because 2 minus 2 is 0, the square root of 0 is 0, and 2 times 0 is 0. So 2 zeros is my first point. 3 minus 2 is 1, the square root of 1 is 1, and 2 times 1 is 2. If you want to write it out, you can. 2 times 6 minus 2 is 2 times 6 minus 2 is 4. The square root of 4 is 2, and 2 times 2 is 4. So 6, let's put 1, 2, 3, 1, 2. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. Last one, 11 minus 2 is 9. The square root of 9 is 3. 2 times 3 is 6. So 11 is at 6. And it looks something like this. Let's keep going. Number 4. This one's pretty easy because the only thing underneath the square root, the radicand, is 0, so x is greater than or equal to 0. And since there's no left or right shift translation, I can just do 0, 1, 4, and 9. Square root of 0 is 0. 0 plus 7 is 7. Square root of 1 is 1. 1 plus 7 is 8. Square root of 4 is 2. 2 plus 7 is 9. Square root of 9 is 3. 3 plus 7 is 10. So 0, 7. 1, 8. 1, 2, 3, 4, 9. 9, 10. So this one looks like that. It's a parabola, kind of hard to draw, especially with my little tool here. X minus 4 is the radicand, so the first thing you do is you say x minus 4 is greater than or equal to 0, which means x is greater than or equal to 4. That's where I start my table, at 4. I'm going to write little helper equations, 1, 4, and 9. Again, these are always the same. The only thing that changes is x minus 4 on the left side. So x equals 5, x equals 8, x equals 13. 5, 8, 13. The square root of 4 is, 4 minus 4 is 0. The square root of 0 is 0. 0 minus 7 is negative 7. 5 minus 4 is 1. Square root of 1 is 1. 1 minus 7, negative 6. 8 minus 4 is 4. Square root of 4 is 2. 2 minus 7, negative 5. 9 square root is 3. 3 minus 7 is negative 4. You should notice a pattern here. Unless there's a 2 or some coefficient here, you should notice a pattern. 4, 1, 2, 3, 4, negative 7. 5, negative 6. 8, negative 5. 13's off the page a little bit. I'm not going to be able to fit that, so it's going to look like this. Again, this one has gone right 4, down 7, so you should look. Right 4, down 7. Cool. I did it right. 2 more. Wait, where'd number 5 go? Was that number 5? Alright. 1 more. So, x plus 1 is greater than or equal to 0. X is greater than or equal to negative 1. That's your domain. X is greater than or equal to negative 1. So when I start my table, I'm going to start at negative 1. Negative 1 plus 1 is, well, let's find the other ones. X plus 1 is 1. X plus 1 is 4. X plus 1 is 9. So x equals 0. X equals 3. X equals 8. So 0, 3, 8. Negative 1 plus 1 is 0. Square root of 0 is 0. 0 minus 2 is negative 2. Plug in 0. Square root of 1 is 1. 1 minus 2, negative 1. Plug in 3. 3 plus 2 is 4. Square root of 4 is 2. 2 minus 2 is 0. Plug in 8. 8 plus 1 is 9. Square root of 9 is 3. 3 minus 2 is 1. So negative 1, negative 2. 0, negative 1. 1, 2, 3, 0. 8, 1. We're good. There's your parabola on its side. And again, you can see it's half a parabola. But this one's gone left 1, down 2. So if I look, left 1, down 2, hey, that's where it starts. The domain is x is greater than or equal to negative 1. Hey, that's where it starts. Negative 1 goes to the right. That's pretty much it for graphing radicals. These are practice problems you should be able to do without a calculator, and then you have the homework assignment to go after that. So go ahead and get that done, and good luck.